Good morning, students. Yesterday we have completed surface chemistry, all the three units, namely adsorption, catalysis, and also colloids have completed. The last part of the colloid was protection of the lyophobic colloid by using lyophilic colloids. Then brief information regarding the colloids around us and also some of the important applications of the colloids we studied. Then we started with a new topic in the organic chemistry, namely haloalkanes and haloarenes. Haloalkanes are also called as alkyl halides. They are nothing but monohalogen derivatives of alkanes, which are obtained by replacing one hydrogen atom of any alkane by any one of the halogen atom like a chlorine, bromine, iodine, and also fluorine. Means they will have a general formula Cn H2n plus 1 X is the general formula for haloalkanes, where N indicates the number of carbon atoms and X indicates any one of the halogen. Whereas haloarenes are the aromatic halogenated compounds. They may be aryl halides or they may be uralkyl halides. Aryl halides means the halogen atom is attached directly to the nucleus of benzene or called as aryl halides, whereas the halogen attached to the side chain of the aromatic aromatic compound are called as a alkyl halides. There are different types of the classification of haloalkanes. No much more classification under haloarenes. Mainly we have to discuss about haloalkanes. One is based on the nature of carbon to which halogen is attached. They may be classified into primary, secondary as well as tertiary alkyl halides. Primary alkyl halide means the haloalkanes in which halogen is attached to the primary carbon. Then the question comes, what is primary carbon? The compound having RCH2X is the general formula for primary haloalkane. For in place of R, you may have either the hydrogen atom or methyl ethyl propyl group may be there in the primary haloalkanes. For example, CH3CH2Br is the ethyl bromide. Whereas secondary haloalkanes means it should have a general formula R-CHX. CH2X is the primary, CHX is the secondary. For example, CH3CH3I is an example for secondary haloalkane. Its name is Isopropyl Iodide. Whereas if all the hydrogen atoms have been replaced by similar or a different groups like a R dash, R double dash, CX are called as a tertiary alkyl halides. For example, CH3CH3CH3 CCl is an example. Its name is tertiary butyl bromide. ಮೇನ್ ನೀವು ಗಮನಿಸಬೇಕಾಗಿದ್ದು RCH2X ಇದ್ರೆ ಪ್ರೈಮರಿ, R-CH ಇದ್ರೆ ಸೆಕೆಂಡರಿ, R-CX ಇದ್ರೆ ಟರ್ಷರಿ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. We have there also we have another type of haloalkanes. Dihalides. Dihalides means they will contain two halogen atoms, but there are two types. If both the halogen atoms are attached to the same carbon, they are called as a geminal dihalides. Geminal dihalides means they dihalogen compound in which two halogen atoms attached to the same carbon. For example, CH3, CHCl and Cl, that is 1,1-dichloroethane is an example for geminal dihalide. Whereas vicinal, this is called Zem dihalide. This is called vicinal dihalide or vis dihalide. Means the two halogen atoms attached to the adjacent carbon. Means adjacent carbon, that is CH2Cl, single bond CH2Cl. This is 1,2-dichloroethane is an example for vicinal dihalides. Geminal dihalides ಅಂದ್ರೆ ಎರಡು ಹ್ಯಾಲೋಜನ್ ಅಟಮ್ಸ್ ಸೇಮ್ ಕಾರ್ಬನ್ಗೆ ಹತ್ಕೊಂಡಿರಬೇಕು. 1,1-dichloroethane. ಆಮೇಲೆ ವಿಸ್ ಡೈಹಲೈಡ್ ಆರ್ ವಿಸಿನಲ್ ಡೈಹಲೈಡ್ಸ್ means the two carbon atoms must attach to the adjacent carbon are called as the vis dihalide or vicinal dihalides. Okay. The second type of classification for the haloalkanes is based on the type of hybridization of carbon. They are classified into alkyl halides, allylic halides and benzylic halides are the three types of alkyl halides based on the nature of carbon in which carbon undergo sp3 hybridization. Second one is based on the type of hybridization in which the carbon atom undergo sp3 hybridization. They are classified into simply alkyl halides, then allylic halides and benzylic halides are the three types of classes based on the type of hybridization in which carbon undergo sp3 hybridization. Alkyl halides you studied already. They are the monohalogen derivatives of the alkanes in which halogen is attached to the sp3 hybridized carbon. Say for example CH3 CH2 Br. Here Br is attached to the carbon which undergo sp3 hybridization. Whereas allylic halides means they are also the monohalogen derivatives of either the alkanes or cycloalkanes in which halogen is attached to the saturated carbon. Say for example CH2 double bond CH2Cl. Though there is a presence of unsaturation, but don't expect sp2 hybridization here because the halogen is attached to the sp3 hybridized carbon atom. This is chloropropene is an example. It may be cycloalkenes also, means to the benzene ring there is a only one double bond, it is a cyclohexene. It will also have the halogen, but that halogen is attached to the sp3 hybridized carbon, therefore it becomes bromomethyl cyclohexene. Bromomethyl cyclohexene is the name of the compound. Benzylic halides are the definitely not aliphatic, definitely they are the aromatic halogenated compounds only, but halogen is attached to the saturated carbon. For example, you have a benzene ring, but the halogen is attached to the saturated carbon. This is isomethyl benzene is the best example for benzylic halide. Any other example? Condition ashte alli halogen is attached to the saturated carbon. That saturated carbon is attached to the benzene ring. Okay. Third type of classification is the type of a classification in which halogen is attached to the sp2 hybridized carbon. They classified it as a vinylic halides and aryl halides. Vinylic halides and aryl halides are the two subtypes in which the carbon to which halogen is attached will undergo sp2 hybridization. Say for example, CH2 double bond CHCl. This is vinyl chloride. In this vinyl chloride, the chlorine is attached to sp2 hybridized carbon. ಏನನ್ನ ಕಂಪೇರ್ ಮಾಡ್ರಿ ಅಂದ್ರೆ ಸರ್ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಲ್ಲ ಅದು ಮತ್ತು ಇದು ಸೇಮ್ ಇದೆ ಅನಿಸ್ತಾ ಇದೆ. ನೋ, ಇಟ್ ಇಸ್ ಡಿಫರೆಂಟ್. ಒಂದನೇ ಎಕ್ಸಾಂಪಲ್ ದಲ್ಲಿ halogen is attached to sp3 hybridized carbon, that is called allylic halide. Vinylic halide andre the halogen is attached to the sp2 hybridized carbon. Okay. Aryl halides you studied already. The aromatic halogenated compounds in which halogen is attached directly to the nucleus of benzene. Directly to the nucleus of benzene means there the benzene carbon in a benzene will undergo sp2 hybridization. For example, chlorobenzene, bromobenzene, iodobenzene are the example where the halogen is attached directly to the nucleus of benzene in which it undergo sp2 hybridization. These are the types of classification of a haloalkanes based on the nature of carbon to which halogen is attached, based on the type of hybridization to which halogen is attached to the carbon. Briefly we can recall regarding the nomenclature. Nomenclature ಬಗ್ಗೆ ಬಹಳಷ್ಟು ಟೈಮ್ ತೆಗೆದುಕೊಳ್ಳೋದು ಬೇಡ, ಯಾಕಂದ್ರೆ ಈಗಾಗಲೇ ಫಸ್ಟ್ ಪಿ ಯು ಸಿಯಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಿ. ಮತ್ತೆ ಸಾಕಷ್ಟು ಸಾರಿ ನಾವು ಪ್ರಿಪ್ರೇಷನ್ಸು, ಪ್ರಾಪರ್ಟೀಸು ಏನನ್ನೇ ಕಲಿಸ್ಬೇಕಾದ್ರೂ ಸಹಿತ ಸಾಧ್ಯದಷ್ಟು ಮಟ್ಟಿಗೆ ನಾನು ಕಾಮನ್ ನೇಮ್ ಮತ್ತು ಇಂಪ್ಯಾಕ್ಟ್ ನೇಮ್ ಎರಡನ್ನೂ ಕೊಡ್ತಿರ್ತೀನಿ. Especially we are bothering about International Union of Pure and Applied Chemistry nomenclature, mainly for the alkyl halides. Okay, IUPAC nomenclature ಅಂತ ಹೇಳ್ಬಿಡಿ ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಜಸ್ಟ್ ರೀಕಾಲ್ ಮಾಡ್ಕೊಳ್ಳಿ. IUPAC nomenclature ಫಸ್ಟ್ ಪಿ ಯು ಸಿಯಲ್ಲಿ ಕಲ್ತಿದ್ದೀವಿ ಅಂತ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡೋ ಹಾಗಿಲ್ಲ. ಇಲ್ಲಿ ಕೂಡ ಕಂಪಲ್ಸರಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅನ್ನು ಕೊಡ್ತೀವಿ. ಬರೀ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀವಿ ಅನ್ನೋದಕ್ಕಿಂತಲೂ many of the questions we are going to ask you to write the answer for the questions in the organic chemistry will have the IUPAC compound name. ಅವಾಗ ನಿಮಗೆ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಕಾಮನ್ ಮತ್ತು IUPAC ನೇಮ್ ಎರಡೂ ಬರ್ತದೆ. ಇಟ್ಸ್ ಎ simple to answer for any questions. Let us take common name in the first column. What is its formula in the second column, and what is its IUPAC name in the third column. Okay. Simplest compound in the haloalkane is methyl chloride. Methyl chloride is a common name having the formula CH3Cl. Its name must be chloromethane. Chloromethane means which halogen is present to the compound, that must be considered as a substituent group. It must be named before to the root word and suffix. Another is ethyl bromide. Ethyl bromide. This is CH3CH2Br. Simply it is bromoethane. Bromoethane like this. Next is isopropyl iodide. Isopropyl iodide is first remember the formula by recalling the name of the compound. Since it is a branched chain, CH3, CHI, CH3 must be the formula. Since it is iodine is present in the carbon number 2, therefore it must be 2-iodopropane is the name of compound. You can have tertiary butyl bromide. Tertiary butyl bromide is important. That is CH3, CH3, CH3 to that carbon Br is attached. It is called as a tertiary butyl bromide ಅಥವಾ tert butyl bromide ಅಥವಾ T butyl bromide. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ನಾವು ಬರೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಅಂದ್ಕೊಂಡು ಮತ್ತೆ ರೂಟ್ ವರ್ಡ್ ಸಫಿಕ್ಸ್ ಅನ್ನು ಅಷ್ಟಕ್ಕೆ ನಾವು ಸೀಮಿತಗೊಳಿಸಬಾರ್ದು. ದೇರ್ ಯು ಶುಡ್ ಗೋ ಫಾರ್ ದಿ ರೂಲ್ಸ್ ಟು ಬಿ ಅಪ್ಲೈಡ್. The longest possible continuous chain of a carbon is chosen that is considered as a parent chain. To that parent chain to which carbon the substituent groups are attached, you must indicate. At the carbon number 2 there is extra group, that is a methyl group, 2-methyl. At the same carbon there is a bromine atom, that is you must according to alphabetical order, instead of methyl first you must name the bromo first. ಹಾಗಾಗಿ its name should be 2-bromo, 2-bromo, 2-methyl, 2-bromo, 2-methyl propane is the IUPAC name. Important example you may expect in the examination for 1 mark. ಸೊ ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಇಟ್ಕೊಂಡು ಸ್ವಲ್ಪ ಏನಾದರೂ ಮಾಡಿಫಿಕೇಶನ್ ಇರ್ತಕ್ಕಂಥ ಫಾರ್ಮುಲಾ ತೆಗೆದುಕೊಂಡು ಹೇಳ್ಬೋದು. ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿನೈಲ್ ಕ್ಲೋರೈಡ್. ವಿನೈಲ್ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮುಲಾ ಈಸ್ CH2 ಡಬಲ್ ಬಾಂಡ್ CHCl. Cl ಇದೆ, ಹಾಗಾಗಿ ಇಟ್ ಶುಡ್ ಬಿ ಕ್ಲೋರೋ ethene. Like this. Then you can take chloroform. CHCl3 is a chloroform. It is trichloromethane because of one carbon. Sir, methane under CH4 ಇರಬೇಕಾ? ಇಲ್ಲ, one carbon with itself. You can have carbon tetrachloride CCl4 tetrachloromethane. Like this, by taking different example, you could give the IUPAC nomenclature. Okay, then we'll bother about the different methods for preparation of the haloalkanes. ಇಷ್ಟು ಕಲ್ತ್ಕೊಂಡ ನಂತರ let us go for different methods for preparation of the haloalkanes. Any other example you can consider? Aromatic ತೆಗೆದುಕೊಂಡಾಗ almost we know that many of the names given for the aromatic compound according to common system, they have been accepted itself as a IUPAC nomenclature ಅಂತ ಒಪ್ಕೊಂಡಿದ್ದೀವಿ. ಹಾಗಾಗಿ aromatic compounds ಅದರ ಬಗ್ಗೆ ಅಷ್ಟೊಂದು ಡೀಟೇಲ್ಸ್ ಬೇಡ. Let us go for different methods of preparation of the haloalkanes. Methods of preparation of haloalkanes. Some of the methods I might have taught already, but the heading given was some important named reactions ಅಂತಿತ್ತು, ಹಾಗಾಗಿ ಕೆಲವಷ್ಟು ರಿಪೀಟ್ ಆಗ್ಬೋದು. ಬಟ್ ಈಗ ನಾವು ಡೀಟೇಲ್ಸ್ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. Methods of preparation of haloalkanes or alkyl halides. Okay, main first method is from alcohol. From alcohol itself we can prepare the haloalkane by 3 methods, by using different reagents to the alcohol. First, sub number A, when alcohol is heated with phosphorus trichloride, phosphorus trichloride, that is PX3, you will get three molecules of haloalkane with the phosphorus acid. You can take examples simultaneously. When the ethyl alcohol is heated with the phosphorus trichloride, it gives three molecules of ethyl chloride with the phosphorus acid. This is ethyl alcohol. Once if you given the name, you should repeat the same thing if it is correct. Same. This is ethyl chloride, or you can call chloroethane. One kade IPAC name, one kade common name for the whole. Sub number B, when alcohol is heated with phosphorus pentahalide. Phosphorus pentahalide, it gives haloalkane. It gives a haloalkane with the removal of a phosphorus oxychloride and HX. Same example I will take. You can do the name by your own. When ethyl alcohol is heated with the phosphorus pentachloride, it gives chloroethane plus phosphorus oxychloride plus HCl. Name neeve carry maadi because same example is taken. Another little important, when alcohol is heated with thionyl chloride, SOCl2 is called thionyl chloride. In presence of a pyridine catalyst, you will get there in the first sub number A and sub number B, you may expect the any haloalkane, but in the sub number C, since the reagent you are using is a thionyl chloride, therefore don't write generally as RX, you must write RCl because no general possible. Then with the removal of sulfur dioxide and HCl, you will get the chloroalkane at the head. This is called it as a thionyl chloride. When alcohol is heated with thionyl chloride in presence of pyridine catalyst, it gives chloroalkane. This process is called as a Darzin's process. DARZENS. Same example, when ethyl alcohol is heated with thionyl chloride in presence of pyridine catalyst, it gives chloroethane with the removal of sulfur dioxide as well as HCl. Okay, but you should remember the name of the method is Darzin's, DARZEN. Darzin's process is the name we have for the sub number C by using thionyl chloride. ಮೂರು ಮೆಥಡ್ ಅಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ ಅನ್ನೇ ಬಳಸಿದ್ದೀವಿ, ಬಟ್ ಅದರ್ ರಿಯೇಜೆಂಟ್ is different. Other reagent you are making use is the different. First sub number A ದಲ್ಲಿ phosphorus trihalide, sub number B ದಲ್ಲಿ phosphorus pentahalide, sub number C ದಲ್ಲಿ particular ಆಗಿ thionyl chloride ಅನ್ನೇ ಬಳಸಿರೋದ್ರಿಂದ you may expect the product must be chloro compound. Therefore, when alcohol is heated with the thionyl chloride in presence of a pyridine catalyst, it gives a chloroalkane with the liberation of a sulfur dioxide and HCl. This process is called as a Darzin's process. ಮೂರರಲ್ಲೂ ಸಹಿತ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ತೆಗೆದುಕೊಂಡಿದ್ದೀನಿ. ಹಾಗಾಗಿ ನೇಮ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮತ್ತು ನೇಮ್ ಆಫ್ ದ ಪ್ರಾಡಕ್ಟ್ಸನ್ನು ನೀವೇ ಬರೀಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡಬೇಕು. ಓಕೆ, we'll go for the second method of preparation of the haloalkane. It is comparatively easier. That is from alkane. Second method is from alkane. You studied last year in the first piece in alkanes, hydrocarbons. When alkane or CH2 CH3 is treated with any halogen like a chlorine, bromine as well as iodine under the sunlight, you will get a substituent product, that is RCH2CH2X is the product formed with the removal of HX. You can take example for better understanding. When the ethane when ethane is treated with a bromine, gas in presence of a sunlight, substitution takes place to form CH3 CH2 Br plus HBr. Simple. Left side you have taken is ethane, right side you got is bromoethane. Like this. Third method is also simple according to me because it is a repetition also from alkene. ನೀವೇ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ನಿಮ್ಮ ಹತ್ರ ಅಲ್ಕೀನ್ ಇದೆ, RCH ಡಬಲ್ ಬಾಂಡ್ CH2 ಇದೆ ನಿಮ್ಮ ಹತ್ರ. ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ನಿಮಗೆ RCH2 CH2X ಬೇಕು ಅಂತ ಆದ್ರೆ ಯು ಮಸ್ಟ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ HX, HCl, HBr ಲಾಸ್ಟ್ ಕಲ್ತಿದ್ದೀವಲ್ಲ ಅದು ಆ ಟೈಪ್ ಕಂಪೌಂಡ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ವಿಲ್ ಗೆಟ್ R CHX CH3, you got it. I'll take example, then I'll inform you to recall the one rule. CH3 CH double bond CH2 is the compound you taken and you added hydrogen bromide without any catalyst. What will you expect? CH3 CHBr CH3. ಇಲ್ಲೊಂದು ಕ್ವಶನ್ ಬರುತ್ತೆ ಏನಂದ್ರೆ, ಸರ್ ಈಗಾಗಲೇ ಅದರಲ್ಲಿ ಯಾವುದು CH3 CH ಡಬಲ್ ಬಾಂಡ್ CH2 ಇತ್ತು, ಮಿಡಲ್ ಕಾರ್ಬನ್ಗೆ ಯಾಕೆ ಬ್ರೋಮಿನ್ ಹತ್ಕೊಂತು, ವೈ ನಾಟ್ ಫಾರ್ ದ ಲಾಸ್ಟ್ ಕಾರ್ಬನ್ ಅಂದರೆ ನೀವು ನೆನ್ಪು ಮಾಡ್ಕೊಳ್ಳಿ, ಇಟ್ ಈಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಮಾರ್ಕೋನಿಕಾಫ್ಸ್ ರೂಲ್. ವಾಟ್ ಮಾರ್ಕೋನಿಕಾಫ್ ರೂಲ್ ಸೇಸ್? The negative part of the molecule added to the double bond gets linked to the carbon containing least number of hydrogen. ಅದಕ್ಕೋಸ್ಕರ ಪ್ರೋಪೀನ್ಗೆ ಹೈಡ್ರೋಜನ್ ಬ್ರೋಮೈಡ್ ಹಾಕಿದರೆ ಒನ್ ಬ್ರೋಮೋ ಪ್ರೋಪೇನ್ ಬಂದಿಲ್ಲ, ಅದರ ಬದಲಾಗಿ 2 ಬ್ರೋಮೋ ಪ್ರೋಪೇನ್ ಬಂದಿದೆ ಅಂತ ಹೇಳ್ರಿ. ಮತ್ತೊಂದು ಎಕ್ಸ್ಟ್ರಾ ಇನ್ಫಾರ್ಮೇಶನ್ ಅನ್ನು ನೆನಪು ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. In presence of a peroxide catalyst, the addition of a HBr on a higher alkene will takes against the Markovnikov's rule, that is called as a anti-Markovnikov's rule or a Koros effect or a peroxide effect. ಈ ರೀತಿ ರಿಯಾಕ್ಷನ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ನೀವು ಅಕಸ್ಮಾತ್ ಯಾವುದೋ ಪೆರಾಕ್ಸೈಡ್ ಬೆಂಜೋ ಪೆರಾಕ್ಸೈಡ್ ರೀತಿಯ ಕೆಟಲಿಸ್ಟ್ ಅನ್ನು ಬಳಸಿದರೆ ಯು ಆರ್ ಎಕ್ಸ್ಪೆಕ್ಟಿಂಗ್ ಅಗೇನ್ಸ್ಟ್ ದ ಮಾರ್ಕೋನಿಕಾಫ್ ರೂಲ್. ಮಾರ್ಕೋನಿಕಾಫ್ ರೂಲ್ ವಿರುದ್ಧವಾಗಿ ಪ್ರಾಡಕ್ಟ್ 1 ಬ್ರೋಮೋ ಪ್ರೋಪೇನ್ ಬರುತ್ತೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಎ ಆಂಟಿ ಮಾರ್ಕೋನಿಕಾಫ್ ರೂಲ್. ಇವುಗಳನ್ನು ನೆನಪಿಸ್ಕೊಳ್ಬೇಕು ಅಷ್ಟೇ. ಇವನ್ ಕೇಳಲ್ಲ ಅಂತಲ್ಲ, ಕೇಳಿದರೂ ಸಹಿತ ಯು ಶುಡ್ ಫೀಲ್ ಈಸಿ ಟು ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಎ ಕ್ವಶನ್ಸ್. ಒನ್ ಮೆಥಡ್ ಫ್ರಮ್ ಆಲ್ಕೋಹಾಲ್, ಅದರಲ್ಲಿ PCl3 PCl5 ಮತ್ತು ಥಯೋನಿಲ್ ಕ್ಲೋರೈಡನ್ನು ಬಳಸಿದ್ರಿ. ಸೆಕೆಂಡ್ ಮೆಥಡ್ ಫ್ರಮ್ ಅಲ್ಕೇನ್ by using the halogen under sunlight. Third method is from alkene, you already studied. ಯಾವ್ದಾರ ಸರ್ ಅಕಸ್ಮಾತ್ ಈಥೀನ್ ತೊಗೊಂಡ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ಬ್ರೋಮೋ ಈಥೇನ್ ಆರ್ ಎನಿ ಸಿಮಿಲರ್ ಪ್ರಾಡಕ್ಟ್, ಅಲ್ಲಿ ಮಾರ್ಕೋನಿಕಾಫ್ಸ್ ರೂಲ್ ಬರೋದಿಲ್ಲ. ಬಟ್ ಇಫ್ ಯು ಟೇಕನ್ ಹೈಯರ್ ಅಲ್ಕೀನ್ ಲೈಕ್ ಎ ಪ್ರೋಪೀನ್ ಬ್ಯೂಟಿನ್ ಪೆಂಟೀನನ್ನು ತೆಗೆದುಕೊಂಡಾಗ ಅದಕ್ಕೆ HBr HCl HIಗಳನ್ನು ಹಾಕಿದಾಗ ಯಾವುದೇ ಕೆಟಲಿಸ್ಟನ್ನು ಬಳಸದೇ ಇದ್ದಾಗ ಇಟ್ ಶುಡ್ ಗಿವ್ಸ್ ಯು ದ ಪ್ರಾಡಕ್ಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಮಾರ್ಕೋನಿಕಾಫ್ಸ್ ರೂಲ್. ನೆನಪು ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. ವಿ ಆರ್ ನಾಟ್ ಆಸ್ಕಿಂಗ್ ಯು ಟು ಗಿವ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ದ ಮಾರ್ಕೋನಿಕಾಫ್ಸ್ ರೂಲ್. ಎಕ್ಸ್ಟ್ರಾನು ಗೊತ್ತಿರಲಿ, ಡ್ಯೂರಿಂಗ್ ದ ಪ್ರಾಸೆಸ್ ಇಫ್ ಎನಿ ಟೈಪ್ ಆಫ್ ಎ ಬೆಂಜೋ ಪೆರಾಕ್ಸೈಡ್ ಆರ್ ಎನಿ ಪೆರಾಕ್ಸೈಡ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಇಸ್ ಯೂಸ್ಡ್, ದೆನ್ the addition of the HBr or any HX to the higher alkane will takes against the Markovnikov's rule. That is called as a anti-Markovnikov's rule. It is called as a Koros effect, or it is called it as a peroxide effect. Okay, these are the some methods of preparation. Similarly, we can also prepare by exchanging the halogen. ಅದೇ ರೀತಿ ಹ್ಯಾಲೋಜನ್ಗಳನ್ನು ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡೋ ಮುಖಾಂತರನೂ ಸಹಿತ ನಾವು ಹ್ಯಾಲೋ ಅಲ್ಕೇನನ್ನು ಪಡೆದುಕೊಳ್ಬೋದು. ದಟ್ ಐ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಇನ್ ಡೀಟೇಲ್ಸ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಬ್ರೀಫ್ಲಿ ಯು ಕ್ಯಾನ್ ರಿಕಾಲ್ there are two reactions, again important. One is Finkelstein reaction, another is Schwarz reaction. Finkelstein reaction indicates that when haloalkane is treated with a sodium iodide, in presence of a dry acetone it gives iodoalkane. ಅಂದರೆ ನೀವು ಸೋಡಿಯಂ ಅಯೋಡೈಡ್ ಅನ್ನು ಹಾಕ್ತಿರೋದ್ರಿಂದ ತೆಗೆದುಕೊಂಡಿರ್ತಕ್ಕಂಥ ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ ಸುಡ್ ನಾಟ್ ಹ್ಯಾವ್ ಅಯೋಡಿನ್. ಅಂದರೆ Cl Br ಮತ್ತು ಎಫ್ ಇರಬಹುದು, ಅಯೋಡಿನ್ ಇರಬಹುದು, ಬಿಕಾಸ್ ಅನದರ್ ರಿಯಸೆಂಟ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ ವಿಲ್ ಹ್ಯಾವ್ ಎ ಸೋಡಿಯಂ ಅಯೋಡೈಡ್. Similarly, Schwarz reaction means when a haloalkane is treated with a silver fluoride, AzF, ಅಂದರೆ ಲೆಫ್ಟ್ ಸೈಡ್ ತೆಗೆದುಕೊಳ್ಬಹುದಾಗಿರ್ತಕ್ಕಂಥ ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ದಲ್ಲಿ ಫ್ಲೂರಿನ್ ಇರಬಾರ್ದು, ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್, ಅಯೋಡಿನ್ ದಲ್ಲಿ ಇರ್ತಕ್ಕ ಯಾವ್ದಾರ ಇರಬಹುದು. When it is treated with silver fluoride, it gives interchange of the halogen will takes place to form the fluoroalkane. That is called as a Schwarz reaction. Finkelstein ದಲ್ಲಿ ಡ್ರೈ ಅಸಿಟೋನ್ ಅಂತಕ್ಕಂಥ ಕ್ಯಾಟಲಿಸ್ಟ್ ಬೇಕು, ಬಟ್ Schwarz ರಿಯಾಕ್ಷನ್ ದಲ್ಲಿ ಯಾವುದೇ ಕ್ಯಾಟಲಿಸ್ಟ್ ಬೇಕಾಗುವುದಿಲ್ಲ. That I can repeat once again. Similarly, we have one or two methods for preparation of the aromatic halogenated compound. Then after that preparation we will go for the important nucleophilic substitution reactions for the haloalkanes, and mechanism will be there for those compounds that we will discuss in the next class. Thank you.